Hi everyone, I'm Megha and I'm an astronomer. Today I'm going to talk briefly about positional astronomy and its significance in Indian heritage and how Indian heritage, is highly influenced by positional astronomy, since times immemorial. And Actually, we were supposed to do this session at the beginning of the camp, but due to some unavoidable reasons it was not available, and we had to postpone it till today. But I'm sure if you have any you know even the tiniest of the doubt about coordinates or anything, it'll get clear today. Otherwise, you can always get back to me on Gmail, Facebook, or in the comment section. So this is an iconic figure, which I think all the Delhites are aware of. It's the Jantar Mantar. And yes, it's part of our Indian heritage. And we are going to see how positional astronomy can be, you know, learned or experienced through such masonry instruments that are there in our country. So, first of all, what is positional astronomy? So, as the name suggests, it's nothing but it's when you know the position of a celestial object, at a given time, at a given date, at a given location, when you are aware of its position. That's positional astronomy, as basic as it is. Okay, so if we talk very, very precisely, in the celestial sphere, okay, wherever you are, and from that point when you look up in the sky and you see a particular celestial object, that's what positional astronomy is. So we talk a lot about coordinates. So I'm sure that during the last 3 weeks, all of you have made a lot of RGB images, and every time you make RGB image, you go to Skyview form and you enter some coordinates, and we all talk about coordinates, coordinates, coordinates. So what are these coordinates? It's nothing, it's just the position of the celestial object. So that's what positional astronomy is. So there are two types of coordinates. Okay, one is horizontal coordinate and one is equatorial coordinate. Now, I'll give you one more example. So suppose I want to visit your house. So I'm going to ask you, what is your, flat number? What is your PIN code? So that's going to be your local address, because we are locally living in India, the domestic address. Uh, or let's say, if I'm in Delhi and if you're also in Delhi, I'm just going to ask, okay, what is your area PIN code? And it's done. Okay, or I'm just going to ask which place you live at, and I'll just come to you. That's the local coordinate. Okay, but if I am trying to meet a friend who's not living in Delhi or living somewhere in some other country, I'm going to ask the details of the address. Okay, so that's going to be the global coordinate. So that's how it works with the celestial objects also. So first of all, we have horizontal coordinate that gives you altitude and azimuth. You must have heard of these terms a lot of times, and today we are talking very, very briefly about all these things, just to give you a glimpse of what it is. Otherwise, during your master's course in physics, if anyone takes specialization in astrophysics, there's a whole course on spherical astronomy, visual astronomy, which you can learn. So altitude and azimuth are nothing but local coordinates when we talk about local time, local position of celestial objects. Okay, so as you can see in the figure, it's when we talk about zenith, this is your zenith, your elevation, that is your altitude. And when you talk horizon, when you look at some object horizontally, okay, east-west direction, that is your azimuth. Okay, so these are your local coordinates, horizontal coordinate system. Then we have equatorial coordinate system. Now, these equatorial coordinate system is nothing but your global coordinate. Okay, right ascension angle and declination angle. So I'm sure throughout the camp, Anand must be telling you what is RA deck, enter RA deck, or if Avi was there in some of the sessions, he must be saying enter RA deck, RA deck. So this is RA deck. Okay, so RA deck is actually mentioned along the longitude and latitude. All right. So it's just that, as you can see in the figure also, RA gives the information on the angular distance between the object and the vernal equinox. Okay. Whereas the declination tells you how far the object is from the celestial equator in the north-south direction. All right. So this is what RA-Dec is. So basically, this is positional astronomy, and then you can go into a lot of details and calculation and derivations when we further study about spherical astronomy. So we don't have to do that right now, but maybe in future we can learn that and take up a session on that. So now we come to Indian heritage in astronomy. Now, how our Indian heritage is influenced by astronomy? This is something very mesmerizing in itself. So these are just 3-4 examples that I have taken. Sun Temple, Konark. It's called Sun Temple uh, because of the way the temple's architecture has been built. And imagine in those times when there was no GPS, no Google, no technology, our ancestors were aware of astronomy, positional astronomy. Similarly, this is Lomash Rishi cave. You can, I mean, since it's not a history talk, so I'm not going to go in a lot of detail of it. I'm just giving you a few examples. Then there is Josset Yogini temple, and this temple is also believed that our Indian Parliament is inspired from this temple, and again it has a lot of astronomical significance. Then you see on the lower right corner, it's the Padmanabham Swami temple, and there's a YouTube link that I have put up. You can always Google about this. Near the equinox, the windows that you see, the 1, 2, 3, 4 windows that you see in the figure, the sun, when the sun sets, it sets in the way that it comes directly in the window. 1, 2, 3, 4. So the precision with which our heritage was developed was totally inspired, or you can say scientific in a manner that astronomy was part of it. Where the sun is rising and the sun is setting, the full moon, new moon, nakshatras, like Lomash Rishi cave is it's got a lot of significance of nakshatras. So moving on, today we are going to discuss about Jantar Mantar. And Jantar Mantar is a masonry, you can say, instrument, a lab that is there. You can go walk in, you can take readings, you can plot graphs, you can see, what is happening in real time, whether it is sun's shadow or whether it is any celestial object, which is obviously visible to the naked eye. You can actually look at it and you can find out its RA-Dec or the local coordinates, that is altitude and azimuth. So since we are not going into the detail, the historical facts, yes, it was made by Raja Savai Jai Singh, and the first one was made in Jaipur. But in total, there were 5 Jantar Mantars. So Jaipur, then there's this one in Ujjain, Jaipur, Ujjain, Varanasi, Delhi, of course, and there was one in Mathura. The Mathura one is not there. I mean, there's some ruins and all. But these 4 places we have got Jantar Mantar, and every um, place has its own significance and its own you would say speciality. There is something in Delhi which is not in Jaipur. There's something in Jaipur which is not in Delhi. So that's how it varies. So so a lot. This is Dr. Ratnashri. She passed away recently during COVID, and we deeply miss her. And she was my mentor for a very long time. I mean, more than a decade. And whatever I've learned about Jantar Mantar is through her, from her. She was my guide, mentor, friend. A lot of roles she played in my life. So I have, recordings of hers, which I'm going to play in between wherever it's required, so that I mean, why should only I have that opportunity? Why not everyone? So I'm going to play this recording of hers, and there are a few more that are going to come throughout the session. And I'm sure it'll help you understand positional astronomy, because she was the pioneer of this field and I'm just a student. So I may not be able to give you everything, but yeah, she still might be able to give you something.
which are there. I would urge all of you to actually visit the observatories and take actual positional astronomy observations. It's great fun and a lot of learning of basic positional astronomy with it. We are walking here through the Delhi Observatory, the Jantar Mantar Observatory, Delhi. To my right is the Misra Yantra, which is relatively unique to the Delhi Observatory. No other Jantar Mantar Observatory has this particular instrument, which is a mixed instrument for positional astronomy measurements. And we are walking now in this north-south aligned path. One thing you would notice in all the Jantar Mantar Observatory instruments being that they have a north-south alignment, and of course depending on what is the exact measurement, so both north-south and the east-west lines become important for the observatory. These are instruments which are essentially going to do positional astronomy measurements based on positions, time measurements, and in general we know them. Most people usually know of them as sundials, as for instance the gigantic sundial here, the Samrat Yantra.
All right. So, in total, when we talk about Delhi's Jantar Mantar, there are four instruments. Like ma'am was also saying, there's one is Misra Yantra, which is totally unique. It's not there in any of the Jantar Mantars, in the four, the other three. And this is supposed to be built by Madhav Singh, Raja Savai Jai Singh's son later on. And then there is this gigantic staircase that ma'am was talking about. It's Samrat Yantra, and there are two more yantras in the backside. Uh, one is Jai Prakas, and the other one is Ram Yantra. So Misra Yantra and Samrat Yantra are primarily sundials, what we call dhoop ghadi. And yes, they talk about they actually give us time, local time of Delhi, as precise as I mean, I think Samrat Yantra has a least count of 2 seconds, and Misra Yantra has a least count of I think 5 seconds, which is very very precise time if we look at it. And the reason these sundials were built, of course, to involve the local public, and because of many reasons, because Raja Savai Jai Singh had a lot of interest in astronomy, and since they are masonry and gigantic, the error reduces. Okay, and as far as I know through ma'am, there are not. I mean the Delhi one and the Jaipur one. I mean the whatever we have in India are the only ones that are so gigantic and huge and masonry. Unlike the ones in Europe. Europe has a lot of sundials, but they're not as big as these. They're not as open as these. For public where you can just walk and take readings. There are sundials across the world, but not like these. So these are really special ones that we have. And then Jayaprakash and Ramyantra they are the instruments that are of our interest because they teach us about coordinates. Okay, so I won't be able to go into too much detail of how the readings are taken, how it's done, because for that we have to actually visit uh, the lab. This is an open lab, that's what we call it. So we have to actually visit the lab and take readings ourselves and see that what is the procedure to do it. So today we're just going to have a little idea that how it's done and what it does. That's all. Okay, so first of all, Mr. Yantra. So I just took up one image from Google. It's a 10 paisa coin, and it's got this iconic figure of Mr. Yantra. And Mr. Yantra is actually mixed, like Misr. It's a mix. It's a mix of many things. Okay, so the dials that you see, these arcs that you see, these are actually sundials, and the shadow you know, goes uniformly in equal intervals of time. So the most of the markings are missing here, and it's very difficult to take readings and data. But with the tape measure and with some basic geometry and maths calculation, we are able to, do it. And like I said, with an error of 5 to 10 seconds only. And apart from that, there's another extra quadrant here that you can see on the left side. And this instrument, I mean, every part of this instrument has got some significance. There is a Rashi Chakra on the right side, which is not visible here. That was a big mystery for Dr. Ratnashri as well. And the back side of the wall is also very, very important because that's the only place in Delhi that's got, a shadow throughout the year. Now, this is something that you guys have to figure out why that's the only place that's got shadow throughout the year, except for one day when the sun is locally on top of our head. Okay, so you have to find out the answer for this and get back to me. And then the triangle walls that you see, these triangle walls, uh, of course they're pointing towards north because the whole observatory is made like that. And also the walls are parallel to the axis of earth. They're made at such a precision, the angle. If you put a big protractor over there, we have actually done those things in the beginning, when 10 years back I'm talking, when we just started taking data and reading and understanding this instrument, we used to put a protector there, a D there, and see that, okay, wow, this wall was made hundreds of years ago, and still, that time it's made at a perfect angle. So that's Misra Yantra. I've got a small recording of Dr. Ratnashri that I'm going to show. So this is basically the diagram. This is the central new moon, where we actually put a pole and we follow the shadow. And there are niyat chakras. There's this extra quadrant that I was talking about, and the quadrants on the west and the east side. These are actually the dials, and all these staircases that are there, they're there because so that we can walk in, and take the readings, because the markings are there all over the place in this, palm leaf shaped figure. The markings are there on the dials. Markings are there, so the markings are there everywhere, and these instruments are made such so that you can walk and take the readings. So I have a small recording of hers.
So we are here in front of the Misra Yantra, which is, as I said, unique to the Delhi Observatory. It has a mix of several functionalities built into it. The basic part of a sundial measurement has this triangular wall and an arc perpendicular to that triangular wall on either sides. There's one on the eastern side, one on the western side. These arcs with the triangular wall built in such a way that the angle inside the triangle being equal to this location, latitude, and the perpendicular arc, making it then parallel to the equator, and the shadow moving parallel to the equator, which essentially ensures that we have an equal movement of shadow in equal time intervals. So that is the part which is on either side of the instrument.
So this is some very brief introduction of Misra Yantra, and yes, it's a very, very complicated instrument because it's got a lot of functionality. A lot of things are happening at one place. So to learn more, we actually have to go there and do it ourselves. And today we're just, getting a hang of it, what it is, and how it works. Okay.
So we are here in front of the Misra Yantra.
All right. So the next one, like I was saying, is Samrat Yantra. Now, this is the second largest of the sundials, you can say, in the world. The largest one is in Jaipur, Ram Yantra. It is even larger than this. So, I mean, one can imagine if this is so large, what will be larger than this? And so there was a time, when people were allowed to walk up this staircase. Like you can see a lot of kids there. Now it's all closed up because a lot of markings are gone. The walls, the platforms that you see, these all of these platforms, these walls have got markings. Okay, and the dials that you see, the dials in the staircase, all of these dials, they have got markings in them. And like I said, it's got a least count of 2 seconds, and we have actually got good data, good readings from this sundial. Whenever we did take readings. So as you can see, the staircase, on top of the staircase, you can see a new moon. All right. So this new moon is actually pointing towards the pole star, Dhruv Tara. And this staircase is just in the direction of the axis of the Earth. That's how it's pointing towards Dhruv Tara. So it's got a north-south alignment, and then there is the staircase, and where again we play a lot with the shadow game of sun and shadow, and we take readings. So a huge part of the sundial is gone beneath the ground, like you can see on the right side. I'm not sure if the cursor is visible or not. On the right image in the right corner, you can see the dials, and they get lost in the ground. So they're actually getting lost in the ground because during the a little before independence, this whole sector was filled with cement, and it was closed because there was a lot of waterlogging, and that waterlogging was actually hampering the base of the instrument. So they just filled it with cement and everything. So a huge part of the dial is gone beneath the earth, but we have still done, readings. We have still taken data on the plane platform, and it has come out considerably good. Okay, so let's hear from her.
This hypotenuse is parallel to the axis of rotation of Earth. And perpendicular to this, we have these arcs. So, perpendicular to the axis of rotation of Earth is the equator. Okay, so you have the equator, these are parallel to the equator. And so, the time on this is such that in this arc, which is half of the full circle, right? This arc is supposed to have 12 hours of time. And we have one half of this arc on this side and one half on that side. What are these sides? One is for the morning side, one is for the afternoon side. The quadrant on the west side will be for the morning, and the quadrant on the east side will be for the afternoon. And this quadrant that you have, for instance, the one in the Misra Yantra, this entire length, if you measure, the entire length is supposed to be equal to 6 hours. Okay? When the shadow is just at the center, it is 12 noon. When the shadow is at the top of the quadrant, it is 6 a.m. When it is on the top of the other quadrant, it is 6 p.m. And you can then divide this into 6 equal pieces. 6 hours. Hours can be divided, subdivided, and so on. And these subdivisions can be very fine if you do it on large quadrant, right? That is why he made such large, gigantic instruments. So that you can make a very fine division of time. And in fact, the least count of this instrument is supposed to be to have in 2 seconds. And in fact, we did observations with this, and up to a second accuracy, this can tell you time. In general, sundials are not thought to be so accurate. And it's only when you have such gigantic scale of sundials and you take careful observations, you can see that they have such accuracy.
So it seems a bit complicated to understand, but trust me, when you are there on site and when you are actually doing it with your hands, it's all very easy and simple. And the way she used to explain us, and when we used to do it, it was all fun. And unfortunately, she's not with us, but thankfully we have these recordings to learn more and understand about this instrument. So
This hypotenuse is
so moving on. So the next one is Prakas Yantra. Now, I've taken these two different images. The left one is from Jaipur, and the right one is from Delhi. So, like I said, every Jantar Mantar, whether in Jaipur, Ujjain, Varanasi, or Delhi, has got its own importance and significance. Now, the Jayaprakash Yantra in Jaipur is relatively smaller than the one in Delhi. So the Delhi ones, like you can see, it's got a walk-in space. So I'll just show you a diagram. Yes. So it's like a bowl. It's like a bowl cut into halves. And then what happens, uh, the place where you see gap, that's a gap where you can actually walk and take readings because the sector has got markings on it. All right. And when there is a replica of this bowl, there's another replica, and both are complementary to each other. All right. So wherever there's a gap here, there's a sector here. Wherever there's a sector here, there's a gap here. Likewise, so that you can walk and take readings. All right. So how the readings are taken? Well, there is a north-south crosswire at the top of this bowl that we tie up, and there is a small hole, like a pinhole. You can say a small hole from which the shadow of the sun falls. And the shadow travels throughout this instrument, and that's how we take readings for sun in particular. I'm talking for sun. All right. If you want to take readings for any other celestial object like moon or some planet like Venus or something, that can also be done. So this instrument in particular is talking about global coordinates that are RA and DEC, right? Ascension angle and declination angle. So Lavanya Nemani, she's another astronomer in Dara at home, India, and right now she's pursuing her PhD from Spain, and she's got a lot of expertise on this, particularly in this yantra. Okay, so maybe sometime we can have her and have a session in detail about this, and she'll be able to explain you more. So this is Jay Prakash. Then we have Ram Yantra. Now, Ram Yantra again is two cylindrical shaped instruments. Again, they are complementary to each other. If you will fit in, they will just fit in to each other. Why? Because there's a sector, there's a gap. There's a sector, there's a gap. And similarly, in the southern one, wherever there's a sector in the northern one, there will be a gap there. Wherever there's a gap here, there'll be a sector there. So they are made with a lot of research and everything. You cannot give any excuse that you're not able to take your readings accurately, because they have provided enough gap to walk in and take the readings. So all the platforms that you see, all these platforms have got markings on them. And the least count of Ram Yantra is, I think, 0.1 degree. So now this is the instrument that talks about altitude and azimuth, like we learned in the beginning of this talk. It talks about the local coordinates of Delhi. And now I have a lot of expertise on this because I have done a project on this, particularly on this instrument. So maybe sometime if we get a chance to visit, we'll go there and we'll take some readings. And we have done, Ratna ma'am and I have done a lot of work on this instrument particularly because this was her favorite as well. And with sun, with moon, with Venus, with anything that is visible in the sky, because these two instruments, Jayaprakash Yantra and Ram Yantra, are nothing but the replica. You can say the whole sky is reflecting on these instruments. Okay, so you stand anywhere in this cylinder and you place yourself on that particular local coordinate of sun, or let's say moon or Venus or anything, and you look up in the sky, and there it is. You can actually find out the local coordinate, the degrees of altitude and azimuth, by placing yourself in this instrument from where that celestial body is visible. So it's very interesting actually. And this is the new moon. So I think at the top of the new moon is the moon. Okay, so you just have to coincide the new moon and the moon or any celestial object that is there and place yourself such that in the instrument, and wherever you are, you just look at what degree you are at. You just check the markings, you see the degree, and you tell, okay, this is the altitude and azimuth of this particular celestial body, and it's done. And it just requires basic trigonometry, basic elevation angle and this that, and you just use basic heights and distance and figure out your angles. So we can actually do this sometime when we visit there. So this was one of our publication towards restoration of Jantar Mantra Observatory, calibration and observation with Jay Prakash and Ram Yantra. So Lavanya is also was also part of it. Like I said, she worked extensively on Jay Prakash. So you can go through this paper whenever you want. And I was working extensively on Ram Yantra, and we had help from other friends and planetarium staff, and that allowed us to publish our work. And then I have another small video of hers that to help you and encourage you to take this up as a project and learn more. So just let me just play this for you.
So I wanted to urge all of you to use your coding skill. You are the one with coding skills. So So here we are at the Jantar Observatory, and some of the work which you could easily do with your coding skills once you understand this observatory would help both for education as well as in astronomy connections with the observatory. So, what I would like to tell you about is what are the instruments here, what is the basic functioning of these instruments, what is their construction, uh, what are the basic elements in this, so that you may be able to recreate them through 3D models or any other kind of analysis oriented work which is required. Essentially, we have here in this observatory, we have instruments which are meant for positional astronomy, and they have very specific designs of construction. Essentially, based on incorporating of spherical trigonometry into this construction, and then they make essentially two kinds of measurements, right? Time and position. And it is position which underlies the measurement of time. Position in the sky. So based on this, let us say shadow falling on any part of the instrument, or we put our eye on any part of the instrument and look through or look in line with a particular part of the instrument, which would be the part of the gnomon of the instrument, and look at the night sky observations, night sky objects. And thereby we know the positions of these objects, position of the sun or the night objects in the sky. So this is essentially what the Jantar Observatory is about. And now I will tell you a little bit of the details of each of the instruments so that you get an idea about it. And I would urge you really to try and make a few 3D models for these instruments.
Okay, so we've done the detailed part. So this was actually some very basic intro about how this observatory can be used to learn, understand, experiment, positional astronomy, to learn about coordinates, to learn about time and coordinates, everything. So like ma'am is saying, you can take a project, you can make 3D models, and we can explore, we can probably set up something like this in different parts of the country, in schools and universities and colleges. I mean, why should Delhi have all the fun, or Jaipur or Ujjain or Varanasi? Why not all the schools and colleges have something like this, to learn and understand, and to experience something which is so magnificent. So well, this is briefly and about position astronomy and Jantar Mantar. And in future, we can take up more sessions like this to talk in detail. And when the things get better, we can always visit the observatory and learn more and experiment and take data and reading and be mesmerized with, how our readings are actually as accurate as the ephemeris. So it's a lot of fun, when we do that. We don't look at the ephemeris, from we take it from NASA's website. We first do our job, we do take our readings, and then when we match, it is so amazing to look at that the error is sometimes negligible. Sometimes there is no error, and that is very fascinating, very fascinating. All right.
So,
So Jantar Mantar, Radha and Megha. So that's one of the picture where it was one of the camps, I think. I can't remember, where I was explaining them about Ram Yantra. And another picture you can see, we are at the GMRT. Shilpa Dubal, she's an operator at GMRT, and she's also happened to be a Radhatom member, ENE astronomer. Then Anand is there, Dr. Anand is there, and then Pratik Tabade. He's a very senior astronomer, as well as he's completed his PhD. Dr. Pratik Tabade, and I'm sure you have heard his talk. And then we have Charitat Vyas. He's also pursuing his PhD from Germany. And the picture in the lower right corner is, where when I started, when I was like like you people. So that's when I started in 2014, when I went to Mumbai and I did a discovery camp. That time it was offline. It was that era when it was done offline. And I became an astronomer and I became a part of Radatome. And I've learned so much with Radatome from my seniors like Pratik, from Anand, from the rest of the astronomers who are like a family to me. And I've been to GMRT, been an observer there. So likewise, all of you can actually do this. It's not something that is not achievable. It is pretty achievable. And I can do it. All of you can do it. So all the astronomers who are going to be astronomers today, all the best, and we are here to help you. And we'll be in touch throughout. Join e-classes, learn more, discover with Rara at home. Okay. Thank you so much. Thank you.